All right, so like I said, linear programming is just going to be an extension of what we did yesterday. We're still going to have to graph some systems of inequalities, but we're going to add another little extra step to that. All right, so let's take a look up at the top here. In linear programming, it says, what do you have? What do you have? You have a blank blank formed by graphing a blank of a blank. All right, so let's fill in those blanks. You have something called a feasible region. All right, so right here, feasible region. You have a feasible region, and that feasible region is formed by a graph of a system of inequalities, which is what we were working on yesterday. That's what we did yesterday, systems of inequalities. It says here, what must you do? Under these restrictions, you must blank or blank some other function. Here's what we're going to do. We're going to maximize or minimize. Maximize or minimize some other function. So there's going to be a third function in there. Not only are we going to have a system, but we're also going to have another function. It says, how do you do it? Well, it says you're going to use the blank of the region. We're going to use the vertices. We're going to use the vertices. And when I say vertices, that's just referring to where the lines intersect at, where they meet up. Okay. So the feasible region is that dark shaded area that we talked about yesterday. What we're going to be looking for is a maximum and a minimum. And those maximum minimums can be found by looking at the vertices. All right, so let's take a look at an example here. Now we're going to start off exactly like we did yesterday. We've got a system of inequalities over here. We've got 3 different inequalities. So we're going to start by graphing this first one right here. We got y is less than or equal to negative 2x plus 4. We're going to do exactly what we did yesterday. We're going to graph that. So we're going to come over here and find positive 4. It's the y-intercept. By the way, guys, if you've got those map colors or different color pens like we had yesterday, let's go ahead and use those again. Negative 2 is our slope, so we're going to go down 2, 1 to the right, down 2, 1 to the right. Now it's very important that this line is extremely accurate, especially in this finding the feasible region. So we need to make sure we're extremely accurate. I'm going to go up 2 over 1, up 2 over 1. Before you connect the dots, double check, make sure you're using the right kind of line. Mine has an equal sign on it, so I need to make sure I'm using a solid line. There it is. But I also need to shade. This says less than, and because it says less than, we should be shading to the bottom. So we're going to lightly shade to the bottom like we did yesterday. Very light. So that's our first inequality. Those of you that weren't here yesterday, this is basically what we did. Now what we're going to do is we're going to take a different color if you have it, and we're going to graph the second inequality, this one right here. We got y is less than or equal to x plus 7. We're going to graph that one next. So positive 7, that's going to be my y-intercept. So let me come over here and find 7. 7, here it is. There's positive 7, the y-intercept. Now notice the slope on that thing is 1. So we're going to rise 1, run. But I need some more points. I'm going to reverse the pattern and go down 1, left. Down 1, left. The more dots I have, the more accurate my line's going to be. Now that I've got those points, I'm going to connect those points. And in my case, I'm going to connect those points with a solid line, because there is an equal sign underneath the inequality. So there's the solid line. Notice it says less than. Less than means we need to be shading to the bottom. So I'm going to very lightly shade to the bottom of that line. We've got one more inequality that we need to work with, and that's this one right here. X plus 3y is greater than or equal to negative 3. Now, right now, I can't graph that because it's not in slope-intercept form. So I'm going to come out to the side and do a little scratch work here. First thing I'm going to do is move the x to the other side. I'm going to subtract it. So I've got 3y is greater than or equal to negative x minus 3. And then I'm going to divide by 3. Remember, there is a negative 1 in front of that x, so that makes it a negative 1/3 x. A negative 3 divided by a positive 3 makes this a negative 1. So here's my new inequality. That's the one I'm going to grab. It's got to be in slope-intercept form first. Yeah, we should have the equal sign. That is correct. All right, so now that we've got it, let's graph it. Negative 1. That is our y-intercept. So let's come over here and put a dot at negative 1. Negative 1/3. That is our slope. So we're going to go down 1, 3 to the right. Down 1, 3 to the right. And get a couple more dots over here by reversing the pattern. I'm going to go up 1, 3 to the left. Up 1, 3 to the left. Once again, we do have a solid line. That's because of the equal sign underneath the inequality. And we're going to shade. Since it says greater than, we're going to shade to the top of the line. So very lightly shade to the top. So everything I've done up to this point is exactly what we did yesterday. Now the last thing we did yesterday was we darkened in the parts where they overlap each other. We're looking for that feasible region. Where do all three colors overlap? Can y'all see it? Where is it? It's that triangle that's in the middle. So we're going to darken that in. That is that feasible region that we were talking about. So darken that in. This again is called feasible region. Now yesterday that's where we stopped. Today we're going to continue here. If you notice underneath that system of inequalities, it asks us to find the maximum and the minimum values for the function c equals 8x plus 11y. So they added this part right here. Well, in order to find that maximum and minimum value, we're going to have to look at the vertices of this feasible region. Now, what do they mean when they say vertices? Y'all talked about it in geometry. When y'all had a triangle, what are the vertices? They're the points. So if you look at that triangle that we just created here, there are 3 points. We got this point right here, we got this point right here, and we also got this point right here. There's 3 points, 3 ordered pairs. We're going to write those 3 ordered pairs right over here underneath where it says vertices. So let's start with this one over here at the far left. What is this ordered pair right here? Negative 6, 1. So write that down. Negative 6, 1. That's one of the vertices. Let's come up to this one up here at the top here. What is that vertex? Negative 1, positive 6. And we got one more. That's this one over here in the corner. This one is, what is that? 3, negative 2. 3, negative 2. So those are the 3 vertices. Now what we're going to do is we're going to plug in those ordered pairs into the actual equation. All right, so right here, we're going to replace the x with a negative 6, and we're going to replace the y with a positive 1. And I want you to put that in the calculator and see what you get. You can type it in just like that. Negative 37. So c equals negative 37 when I plug in a negative 6 for the x and a positive 1 for the y. But we got to do that 2 more times. The next one I'm going to use is negative 1, positive 6. So again, same thing. We're going to replace x with negative 1. We're going to replace the y with the 6. We'll put that in the calculator just like the last one and see what number we get this time. What was it? 58. All right, one last time here. Replace x with a 3. Replace y with a negative 2. And let's see what number we get this time. 2. So the values of C were negative 37, 58, and positive 2. And we got those by using the vertices. Now, the question was, what is the maximum? And what is the minimum? What is the maximum value? And what is the minimum value? Well, look at the C's that we got over here. Let's start with the maximum. What was the biggest number we got? 58. So 58 is our maximum. Minimum. What was the smallest number we ended up with? Negative 37. That was the smallest number we got. Therefore, it is our minimum. So we've just found the maximum and the minimum using those vertices of the feasible region. So that's the extra step that we're adding today. Not a whole lot different, just a little extra step. All right, so that takes care of the first one. Let's do one more of these here. Number 2, again, same thing. Let's take this first inequality and let's graph it. Luckily, it's already in slope-intercept form. So positive 4 is where I'm starting. Negative 2 is the slope, so I'm going to go down 2, 1 to the right, down 2, 1 to the right. Again, it's extremely important that this line is accurate, so get as many points on there as possible. What kind of line are we going to use on this? Solid. Connect those dots with a solid line. This one says less than, so we're going to lightly shade to the bottom. So there's your first one. And those of you that got different colors, now we're going to graph the second inequality in a different color. We're going to graph y is greater than or equal to negative 1/2 x minus 2. So minus 2 is going to be our starting point. That's our y-intercept. The slope is negative 1/2, so we're going to go down 1, 2 to the right, down 1, 2 to the right, down 1, 2 to the right. I want to get some more points over here, so I'm going to reverse the pattern. I'm going to go up 1, 2 to the left, up 1, 2 to the left. This also has an equal sign, so I'm going to make sure I use a solid line. There's my solid line. It says greater than. Greater than means we should be shading to the top. So lightly shade to the top. That'll take care of the second inequality. And now we have left is one more. Last one we have to work with is that x is greater than or equal to negative 2. Now notice there is no y on this one. So what kind of line do you get when there is no y? This one? Vertical line. It's going to be a line that goes straight up and down. That's what we're looking for. All right, so let's go ahead and graph that. Negative 2 is the y, not y, but x-intercept this time. So it's got to go to negative 2. It's going to be another solid line, straight up and down there. Now remember, there is no top and bottom for a vertical line. There is no top or bottom. It's just a left and a right. So the question is, where am I going to shade? To the left or to the right? Now right here, look what it says. X is greater than a negative 2. So we want to shade the side where the x values are greater than negative 2, which would be to the right. So we're going to shade to the right. Now that we've done all of our shading, now we're going to darken in that feasible region, the part where all three colors overlap. Once again, it's going to be a triangle that's in the middle. Here it is. This is where all three colors meet up. This is what we're calling the feasible region. Now notice these two examples that we've done have been triangles. It's not always a triangle. Depends on how many inequalities we're given. This one happens to be a triangle, which is also going to give us three vertices, just like number one. This would be one of the vertices. Here's another one. And another. These 3 points Those are the points I need to write over here where it says vertex. All right, so let's start with this one way up at the top over here. What is that vertex way up here at the top? -2, +8. That's one of the vertices. Let's come right below that one. The next one right here would be a -2, -1. And we got one more, and that's this one down here at the bottom, and that one is, what is that? 4, -4. So those are the three vertices. Those are the numbers I'm going to have to plug in for x and for y. All right, so here we go. This is the function or the equation they give us. So we're going to replace x with a -2. We're going to replace y with 8. We're going to stick that in our calculator and see what number we end up with. -62. -62 is what we get. Let's do the same thing for the next one. We're going to replace x with a -2. This time we'll replace y with a -1. And let's see what number we end up with this time. +1. And one more time here. This time we're using a 4 for the x. A -4 for the y. So when you put that in your calculator, you're going to get a, what? 40. 40 is what you get. Now what we're looking for is the maximum and the minimum. That's what we were asked to find. So let's start with the maximum. Now that we have the numbers, we got a -62, a 1, and a 40. Which one of those is the maximum? 40. It's the biggest number. Minimum. Now we're looking for the smallest number. The smallest number we have there is the -62. So we got our minimum and our maximum. All right, guys, this takes care of linear programming.